What should be conditional event? You must know that, please. First, what is a conditional event? What is a conditional event? So, conditional event is that event when an event to occur, another event must occur. That means the occurrence of one event follows the occurrence of another event. Very simple, you can understand that. India is playing cricket with other countries. It has two recent matches, because I'm not, I don't waste my time in looking after the cricket and all, but I know that India did not even enter into semi-finals, isn't it? The reason is, there is a condition that this much get these many points to enter into semi-finals or into finals. This must get some points in semi-finals, then only it will be entering into finals. Like that, the condition is imposed there. For example, if you take A is such an event, getting admission into BTech, let me say, getting admission into BTech or getting admission into graduation. What is it? Getting admission into graduation. Okay. Getting admission into graduation, whatever it is, BTech or BSc or whatever it is, it's a graduation, generally under graduation. And B is such an event. To get admission into graduation, you must pass 12th class. Passing 12th or intermediate, whatever it is. So passing 12th will give you admission into graduation. These are the two events I have taken. What is it? B, passing 12, and A, getting admission into graduation. So, which one must occur first? It's common sense, you can understand. B must occur first. Then only A occurs. So, it is termed as A after B, which is nothing but a conditional event. So, A after B means B must occur first, then only you must pass 12, then only you will be getting admission into graduation. This is nothing but a conditional event. For example, another example. A is promotion to 12th class. B is passing 11th class. Should I repeat? A is promotion to 12th class. B is passing 11th class. Whether it is intermediate or CBSE or ICSE or whatever it is, passing or promotion to 12th class generally does not depend on passing 11th class. Then that is not a conditional event. That's not a conditional event. So, whatever the case generally you take up, generally, even in the sports or even in your competitions, if I, for example, now very important thing, like you have JEE main, you have JEE advance, let us take this more lively example, you'll also enjoy it. JEE main, you must get a rank below 1,50,000. Below 1,50,000. That means if 20 lakh students are appearing for this examination, you must be below 1,50,000, or if you come under non-reserved category, you must be below 75,000. That means you must be the topper among all the 75,000, you must be one of all the top 75,000 students. if you belong to non-reserved category. If you belong to reserved category, generally they take 1,50,000 up to 1,50,000. So getting a rank in JEE main, if you take it as A, if you get it, then you are eligible to appear for JEE Advanced. JEE Advanced. So if I say this as A and if I say this as B, B to happen, A must happen first. B to happen, A must happen first. So whatever there in the denominator, then that must happen first to happen this one, B. Okay. So this is B after A or B given A. It is read as B after A or B given A. This is read as A after B or A given B. Given B means you must know, to this event to occur, you must know that your rank should be less than 1,50,000. This is nothing but a conditional event. So for an event to occur, there is a condition imposed. That is nothing but the conditional event. Now, basing on this conditional event, conditional probability is defined. What is the conditional probability? You have learned the definition in your board level itself. Conditional probability, that is, let A and B be any two events in a sample space S such that the first occurring event's probability is not equal to 0. If I write P of A not equal to 0 and P of B not equal to 0 if it is in the denominator, I'll write that also. So I repeat, let A and B be any two events of a sample space S and P of A not equal to 0, let me say. Then the probability of occurrence of an event B after the event A is defined as probability of A intersection B upon P of A. Because it is in the denominator, we already defined that P of A not equal to 0. This is nothing but the conditional probability. Similarly, P of A after B can also be defined. It is nothing but P of A intersection B upon P of B. So whatever is there in the denominator, that here in the denominator, that comes in the denominator again. Understand that. So how do you understand this? Now, if I apply the classical definition on probability, it is nothing but N of A intersection B upon N of S upon N of A upon N of S. So what happens? This N of S getting cancelled, and your formula now will be simplified to number of outcomes in N of that is A intersection B, that is number of outcomes of A and B whole divided by number of outcomes of A. What was the previous formula? Number of favorable outcomes divided by total number of outcomes. But here the denominator restricted. That's only the thing. The classical definition always holds good, but further what happens? Restrictions are imposed and the denominator changes. There it was N of S means total number of outcomes we take, but it gets cancelled anyway. You need not have to have that. So in this case what happens? N of A intersection B upon N of A. Similarly, if you write the same for this one, it is also N of A intersection B upon N of B. Understand that, please. In this case, P of B not equal to 0. This is it is understood because it is in the denominator. So I'll take an example, better example to explain this. Conditional probability. Let A and B be any two non-empty sets of a sample space S such that P of A not equal to 0 in this case or P of B not equal to 0 in this case. Then for the probability of the occurrence of an event B after the occurrence of event A is defined as probability of P of B after A or P of B given A is nothing but P of A intersection B upon P of A. After simplification using the classical definition on probability, it is nothing but N of A intersection B upon N of A. N of A intersection B upon N of A. Similarly, it can also be simplified. Now, basing on conditional probability only, next multiplication theorem will be derived. It's very simple, and if you are given multiplication theorem or compound probability, it is also said to be compound probability, just you have to cross multiply this. That's all, nothing more than that. Cross multiply this to get the multiplication theorem. We will be discussing that now. But before that, you will be exactly understanding this definition. If I take an example, I'll take an example. 2 dice are taken, they are thrown, and I gave you that the sum on the dice is 8. It is given that the sum on the dice is 8, and then I ask you a question: what is the probability of getting number 2? What is the probability of getting number 2 on the dice? So in this case now, I'll keep this like this. Now the example what I have taken is nothing but 2 dice taken and thrown. 2 dice taken and thrown. Then the total number of outcomes are 6 square. That is 36. I don't need all these things because my sample space in this case, or our sample space in this case, is restricted. Restricted to what? Total sum on the dice is given to be 8. Total sum on the dice is given to be 8. So what should be now the outcomes if the sum is 8? If it starts from 1, 6 is the maximum combination, which becomes 7. So it is not possible. So 1, 7 is one possibility. And similarly, 2, 6 is another possibility. And 3, 5 is another possibility. And 4 is another possibility. And next, 5, 3 is another possibility. And 6, no other combination for this one. So how many outcomes you have got? If you throw the die twice and I gave you that the sum on the dice is 8, how many outcomes you have got here? 1, 7, 2, 6, 3, 5, 4, 4, 5, 3, 1, 2, 3, 4, 5 you have got. That is, I'll say it as N of A is 5. This is nothing but 5 I have got now. Now, what is my B in this case now? Getting number 2 and as well sum 8. Getting number 2 and as well sum 8. Getting number 2 and as well sum 8 means you can choose any one of this, but you must have 2 on the die. How many cases are there here? Only one case is there. So getting number 2, if I take it as B, then my N of A intersection B, what does it mean? Intersection means and. Remember, and means sum 8 and containing 2. Sum 8 and containing 2. How many are there? Only one is there. So my N of A intersection B is only 1. So in this case now, what should be the required answer? In this case, it is nothing but P of B after A. This one, P of B after A. What is B? What is B? Getting sum and getting sum 8 and getting number 2. Getting sum 8 and getting number 2 on it. That is B. What is A? The sum should be 8. What is A? The sum should be 8. How many are there? 5 are there. So here my denominator fixed 5, and what is the numerator? 1. So 1 by 5. Understand? You need not have to write the entire sample space. In case of conditional probability, the denominator, if you write the classical definition on probability, this N of S gets cancelled. Your N of S gets cancelled. That is why you understand the classical definition. If you understand properly, in the conditional probability, that denominator is restricted like this. Instead of getting 36, because 36 should be the total number of outcomes anyway, that will be getting cancelled. That is why you can remember, or you can see the conditional probability like this. Okay, so P of B after A, or P of B given A, is nothing but P of A intersection B upon P of A is the definition of conditional probability. And if you want to convert this into elements, number of elements, like number of elements in A intersection B upon number of elements in A. Intersection means, understand, it is and. Number of elements in A and B A and B means getting number 2 and the sum 8. It is only 1. And n of A getting sum 8. How many are there? 5 are there. It is 1 by 5 like that. So it is nothing but the compound probability. And if you extend this to multiplication theorem or conditional probability,